Hello everyone, welcome to the live class. So guys, today we are having another session in which we will discuss atomic and molecular physics previous year questions. So I hope the discussion which we have done in the previous classes that will be clear to all of you, and today we are going to apply all those concepts and the formulae and methods which we have discussed in the previous two classes, okay, in these questions. And we are even going to observe that what type of questions have been asked in the previous years. So I hope that with today's session you will get a clear idea about solving the questions. Also, if there is any doubt from the previous classes discussion anybody is having, you can let me know about it. We'll try to consider those points too. And here is your first question of today's session, which has been asked in the previous years. Let me just check your comments. Just a second. Let's just start the discussion about the question. And whatever methods I have discussed with you, you will try to solve the questions by applying those methods, so that you will get like whether they are working and how easily you are able to get the answer with those methods. Okay. Excuse me. This is from the previous year's CSIR Net Physics exam. And if you have already solved it, still try to consider the complete process once and then answer it. Decreases by 2, decreases by 4, and does not change. Once you will get it done, you can let me know which option is correct according to you. Guys, it will get okay, the background noise अभी ठीक हो जाएगी. Kirti, basically once we are going to fill one particular orbit completely, then we are going to consider the electrons in the next one. Okay, so in this case any one should be completely filled. Like I will take one example after this question which has been asked in the previous years, so you will get the idea from that कि कौन सा वाला consider करना है. ठीक है, एक और example आएगा ना इसके बाद में, you will get the idea. Okay, very good Shaboni. Guys, it will get okay. Very good Sahil, very good Sayanika, very good Sayada, very good Subramanyam, very good Vandana, very good Payal. So option B, option C and option D you have selected. Okay. Now let's finalize it that which one is going to be correct. So if I'm going to talk about the question, this has been asked in the previous years. Very good Jayesh, very good Debajani, very good Mitali. Okay, very good everyone. But different answers I have got from your side. Option B, option C and option D. Nobody has selected option A yet. If anybody wants, they can say okay from my side option A. If you want, you can. Okay, it's free. Clear. So if we are going to talk about this one, it's gonna be how much does the total angular momentum quantum number J change, okay, in the transition of chromium, this is Cr, 3d6 atom as it ionizes to chromium 2 positive and it becomes 3d4. The point is how we can get to know about the change in angular momentum value. See, if we are having two different structures, two different systems, and if we will compare their ground states, because there will be same difference in the J values. If I am comparing the first excited state with the first excited state or ground state with the ground state of two different systems, whatever difference we will have in the J values for two corresponding ground states, the same difference in the J values we will get for the first excited state. So let's check for the ground state first. And yesterday I have told you one method which will help you to get the ground state spectroscopic terms easily. Okay. Also guys, you can observe one thing, that in CSIR net exam they give the questions very smartly. See how this question is going to have a smart factor in it. What is that? You can see D6 and D4. Are they inverted multiplets? Yes, they are inverted multiplets. And when they are inverted multiplets, we know that their spectroscopic terms will be same. And that's how even if I am finding the spectroscopic terms for the ground state, for finding the ground state with one, I can say for the other one even I will get same. Okay, so let's try to consider it. D6. 1, 2, 3 and one more partition should be there for D case. It's gonna be D6. How I will fill? As per Pauli's exclusion principle, we need to consider first 1, 2, 3, 4 and 5 and 6. Done. Okay. Next, for the ground state, one method I have explained you yesterday. That same method I am going to apply right now. Okay. What is the summation ml value? Because you know plus 2, plus 1, 0, minus 1, minus 2. What will be summation ml? For each electron you need to write. For this one, it's plus 2. For this one, it's plus 2. For previous one, it's plus 1. For this one, it's 0. I hope it will get okay soon. Okay. Next, for this one, it's minus 1. For this one, it's minus 2. Then simplify. Cancel, cancel. You are going to get cancel, cancel. You are just going to get 2. Done. 2 means what? D. Okay. Now again, one more thing. If I am going to consider the spin, you can consider plus half, minus half, 0. Plus half, plus half, plus half, plus half. That means 4 by 2, which means 2. So spin is what you are getting, the spin 2. And also the value of L is 2. So J will be L minus S to L plus S. That means 0, 1, 2, 3, 4. Is it the same you are getting or is there any difference? If yes, you can tell me about it. So you are getting D, 0, 4, 2, 3, 4. Also it's going to be number of unpaired electrons plus 1, which will be 5. Number of unpaired electrons 1, 2, 3, 4. 4 plus 1, 5. Okay, it's 1. Now the point is we are going to compare the ground state spectroscopic terms J value. What will be that? See guys, I have told you for the inverted multiplets the spectroscopic terms will be same. That means for D6 and for D4 they are going to be same. Same for D4, same for D6. But the point is there will be a difference in the ground states. D6 is more than half filled case. For the more than half filled case, in that what is going to be the ground state? The largest J value will have the largest energy. D4, sorry, the lowest energy. That means for the ground state, the J value is 4. Okay, for which case? For the D6 case. Okay, ground state J value is 4. Now for the D4, which is less than half filled case means lowest or the lower J value will have the lowest energy. So that is 0. Okay, so now for D4 case, the ground state will have the J value equal to 0. Initially it was 4, now it is 0, which means it has decreased and decreased by the value 4. So what is the right option? Decreases by 4. And this method is going to work just to know about the ground state, which I am discussing right now. Is this clear to everyone? हाँ कीर्ति, देखिए आपने एक क्वेश्चन पूछा है इसमें कि इसमें हमें कैसे पता चलेगा कि हमें ग्राउंड स्टेट के लिए फाइंड करना है। तो उस पॉइंट को मैंने स्टार्टिंग में क्लियर किया कि मान लीजिए आपको दो सिस्टम्स को कंपेयर करना है, ठीक है, आपके पास दो सिस्टम है, यू वांट टू कंपेयर दैम, यू वांट टू नो व्हाट विल बी द डिफरेंस इन द वैल्यूज ऑफ जे और एनी सच वैल्यू। तो अगर आप उन दोनों सिस्टम्स की किसी एक पर्टिकुलर स्टेट को कंपेयर कर लें तो आपको पता चल जाएगा कि अच्छा ये डिफरेंस है इनकी वैल्यूज़ में, ठीक है। तो हमने क्या किया, हमें पता है कि ग्राउंड स्टेट फाइंड करना हमारे लिए ईजी है, हम हर टाइम हर क्वेश्चन में ऑलमोस्ट इस टाइप के ग्राउंड स्टेट्स फाइंड करते हैं। तो हमने ग्राउंड स्टेट फाइंड की दोनों केसेस में, और उनमें जो जे का डिफरेंस था हमने कहा ओके दिस इज द डिफरेंस। क्लियर? तो दिस इज लाइक ये अप्रोच हम डिसाइड कर रहे हैं कि हम ग्राउंड स्टेट्स को कंपेयर कर लेते हैं, लेकिन हमें क्वेश्चन में सिर्फ ये पूछा गया था हमसे कि we need to find the difference or how the J value is getting affect with this transition. Okay, so is that clear to everyone? Is this clear to everyone? Done? If there is any other question you can tell me about it. If no, let's talk about the next question then. And this question has been asked in the June 2014 CSIR net physics exam. June 2014. Okay, so this was from the previous years. Now next question. Just a second. Done? See, the next question is, of the following term symbols, of the NP2 atomic configuration that is 1s0, 3p0, 3p1, 3p2 and 1d2, okay, which is the ground state? That's the question. Clear? And the options are, and you can see what type of questions have been asked. Clear? They will provide you an idea about the different types, also what can be there in your upcoming exam. Try it once and let me know which option is correct according to you. Payal, I think अभी शायद बंद हो गई, हो जानी चाहिए. Clear? Once you will get it done, please let me know which option is correct according to you. Very good, Kirti. Very good, Vandana. There's 2 answers till now. Waiting for more. Very good, Sanika. Very good, Subramanyam. Very good, Sahil. Very good, Mitali. So till now I've got 2 answers from your side, option A and option B. Very good, Devajani. Very good, Monica. Very good, Yashika. Very good, Jayesh. Okay, now we have got option C as well. So A, B and C. What about others? Oh, the last one. Very good, Mithili. Very good, Shaboni. The last one is 3P1. Okay, this is 3P1. Very good, Jayesh. Very good, Yashika. Very good, Debajani. Very good, Monica. Very good, Mitali. Okay, that's good. Let's talk about it now. The question is, we just need to find the ground state. Okay, they have given us the spectroscopic terms as well. Now the point is, we all know about the Hund's rule. How we compare the ground state then? Firstly, we check the multiplicity S. 2S plus 1 basically, that is capital S. If you are going to check the multiplicity, the largest S term will have the lowest energy, which means this, three are having the largest 2s plus 1 value, which can be possible ground state. But the point is, we can only have one as the right answer. So how we will decide? Then we will talk about the L value, orbital quantum number, or here in the spectroscopic term, the capital L we are having. So then we know largest L term will have the lowest energy, but the point is all are P. So how we can decide which is the largest one? All are same, we can't decide with that too. Then we have to check for the J values. So this is P2 case. P2 means less than half filled case. When it is less than half filled, we know that that lowest J term will have the lowest energy. So 3P0, we just need to use these rules and we can get the answer. And that's option A, which is going to be the right option. Is this clear to everyone? So you just need to recall the statements of Hund's rule to answer such type of questions. Is that okay? So you can see in June 2015 they have asked the question which is directly just related to ground state. Even they have given you everything. Is that okay? If there is any doubt you are having, please let me know. We are going to talk about the next question as well. Okay, the next question is the LS configuration of the ground state of magnesium, then you are having aluminium. They have given the atomic numbers here. Then you are having chlorine and argon 18, okay, are respectively and the options are 3s1, 2p1 by 2, 2p1 by 2 and 1s0, and you can start finding them if you want. I am even going to show you the options, but you can start doing it. One s 0, 2p3 by 2, 2p1 by 2 and 3s1. Once you will get the answer, please let me know. How? Payal, is there any doubt? If yes, please let me know. Very good, Sayanika. Very good, Asha. Very good, Rashmita. Very good, Sahil. Very good, Shaboni. Very good, Vandana. Payal, in the previous question, we have just considered the statements of the Hund's rule. Okay, as per the statements, if any orbital is less than half filled, like P2, in the P orbital we can have total 6 electrons, but only 2 are present, which is the case of less than half filled. And in this case, when it is less than half filled, you can have the lowest energy term, if you are comparing it with after comparing with 2s plus 1, after comparing L, then you go to J. Okay, if it is not possible for you to get one particular ground state spectroscopic term by comparing multiplicity and L value, when you are going to move towards J, it becomes important to observe whether it is less than half filled case or more than half filled case. So P2 is the less than half filled case. In that case, the statement is lowest J term will have the lowest energy. That means lowest energy means the ground state. So what is having the lowest J term? So that is 0, 3p0, and that's the answer, option A. For that you need to know the Hund's rule statement. Very good, Sanika. And very good, Subramanyam. Very good, Yashika. Pal, I've repeated that. I hope now it will be clear. Very good, Shaboni. Very good, Vandana. Very good, Kirti. Very good, Mithili. Very good, Yashika. Very good, Devajani. Very good, Sangam. Very good, very good, Subramanyam. Very good, Jayesh. Very good, Kirti. Clear. Any doubt anybody is having in this question? So guys, in this question you can work smartly. What is the smart work you can do? Let's talk about it. See, if I'm going to talk about magnesium, okay, 12. Now the point is, if you are going to write its configuration, so what you will get, if you want to write it completely, you can write it. I'm just going to show you on the next slide. For 12, you will write 1s2, 2s2, 2p6 and 3s2. Okay. Another thing, you are having the another one, 13 for aluminium. Okay. When you will write for this one, 1s2, 2s2, 2p6, 3s2, 3p1. Okay. Next, if I am talking about the next one, that's 17, which is 1s2, 2s2, 2p6, 3s2 and 3p5. And then if we are going to talk about argon, 18, in that case this will remain same, 1s2, 2s2, 2p6, 3s2 and 3p6. If you are going to observe this last one and this first one, even if you want to observe the sequence, see, 12, 13, 17 and 18. I have written it in sequence, 12, 13, 17, 18. The last one is completely filled. And in yesterday's class, if anybody is here who has missed the last session, last two sessions basically were for atomic and molecular physics, where I have explained these concepts. Okay, so you can watch those sessions, it will get more clear to you. Excuse me, whenever the completely filled sessions we are going to have, the corresponding ground state spectroscopic term will be 1s0 always. That means for 3s2 and 3p6 it's gonna be 1s0. Only in one option it's 1s0 present. Okay, just by checking this thing we can say, oh, option C is correct, because only that is satisfying this condition. And this is like in sequence it has been written, okay, all the terms. So directly you can say option C is correct. You don't even need to find for all the cases. Even if required, you can find them. We all have discussed, we have discussed the process to find them. Also, whatever spectroscopic terms you will have for P1, same will be for P5. Another thing, there will just be difference in the ground state spectroscopic terms. This one will have the lowest J value will have the lowest energy. For this one, largest J value will have the lowest energy, because it is more than half filled, it is less than half filled case. Okay, is this clear to everyone? Or if there is any doubt, please let me know. Kirti has asked one question. For 3p1, how we will write the spectroscopic term? Clear? Now the point is, what is the value of L, guys? For L, for P case, what will be L? That's gonna be 1. What will be the spin? See, I am telling you for one equivalent electron, even if it is D1, even if it is P1, S1 or any one. Okay, so in that case you are going to follow this process. Spin for one electron will be half. So now the point is, what will be the value of J? That will be L minus S to L plus S. Okay, now the point is, what you need to do, L minus S means 1 minus half to 1 plus half. Clear? Now the point is, you are going to get half and 3 by 2. Two values you have got. Also for L is equal to 1, what will be the value of capital L? That's gonna be P. Okay, and 2s plus 1, that's going to be 2 into half plus 1, which means 2. And the values of j, you have got 2, 1 upon 2 and 3 by 2. Another method I have told you to find the ground state. But even with that, you will get both these terms, and for all the cases when only one equivalent electron is there, you can follow it. It is 3p1, 3p1. In this case, what will happen? How many electrons are there? 1 only. Fill it here. Also write plus 1, 0, minus 1, the ml values, because we know for p, l is equal to 1, so we'll write the ml values like this. Only one electron, we have filled it. What is summation ml you are getting corresponding to the electrons present there? Only plus 1. Okay, next thing. If we are going to talk about the another point for plus 1, what will be the capital L value? That will be capital P. What will be the spin for this? That's gonna be half. So same thing we are doing right now as well. So it's gonna be 2s plus 1 Lj. J will be equal to L minus S to L plus S, which means again 1 minus half to 1 plus half, which you are getting like same expression as we have got here, and this is the term you can get. Is this clear to everyone now? That what is going to be the process? I've explained both. Either do like this or do like this. The last step will remain same to find the value of j. Clear? Done? If there is any doubt, you can mention and you can let me know about it. If it is clear, that's good. Your next question. And it's gonna be, that's good. Guys, next question is here again from the previous year CSIR net physics exam and from June 2016. The ground state electronic configuration of which state in the standard notation, this is notation, is not possible in this configuration. Quickly you can start solving it. I'm even going to tell you all the options and do it with the process, okay, like complete process. Try it once and let me know once you will get the answer. Shaboni? Huh, that's correct. It is less than half filled, so you can even just find L minus S if you just want to know about the ground state. But I was finding all the spectroscopic terms for the one equivalent electron, one valence electron case. That is the process. That's why we have considered it in that way. We have considered all the terms, and then we are finalizing the one particular term. Very good Subramanyam, very good Sayanika, very good Payal, very good Jayesh, very good Arsha, very good Shaboni, very good Payal, very good Debajani, very good Vandana, very good Sangam, very good Sahil. 4 3 2 1. Okay, 0 1. ठीक है, okay. Very good Karishma, very good Sahil, very good Subramanyam. I think everybody is getting the right answer for this. If anybody will not get, please let me know. I will discuss. If everybody is getting, that's good. Clear? And guys, for this question, option A is correct, which everybody has got till now. So I hope it's clear to all of you. And is there anyone who is not getting it? You can use the Bright's scheme. I have explained it in the last class. So let me know once you will get it done. Also guys, till then, thank you so much everyone for joining this session. I hope it was helpful for you and you have got to know about the related questions, okay, related to spectroscopic terms. There are even some more questions you can get. In December 2019 you had one more question, you can try that too. You know every point which you need to solve any question from the previous year CSIR net physics exam. If somebody is just attending this session right now, I have conducted the two more sessions before this exactly. Okay, we had two more sessions of atomic and molecular physics. If you will check that session, okay, so in that case you will get atomic and molecular physics written in the title. You can check them and you will get to know about all the process to find the spectroscopic terms which we have discussed till now. And till now whatever questions we had in the previous years, they are all from that particular procedure. Okay, also guys, if you want to attend more regular live classes by all the top educators we are having on Unacademy Plus for your upcoming CSIR net physics exam preparation, then you can take Unacademy Plus subscription. Okay, Ravi, I will discuss. Barsha, I will discuss it. Don't worry, I will discuss that question. Also guys, while taking the subscription, you can use the referral code, that is Anjali Arora. You can apply it, write it in the same way, like no space in between. Okay, spelling should be same, write it, apply it and get the 10% discount in the total Unacademy Plus subscription amount. Also guys, after taking the Unacademy Plus subscription, you will get so many benefits, like weekly quizzes will be there, doubt clearing sessions will be there, mock tests will be there, PDF of important notes will be available to you. So with all these things, you will be able to do very good preparation for your exam, and all these Unacademy Plus courses will help you to do the best possible preparation in the limited time. Clear? So, and you are going to get the guidance by all the top educators which will surely help you to do the best preparation for your exam. So I hope everything is clear to all of you. Also guys, by using and by applying the referral code, that is Anjali Arora, as I have mentioned it here, you can write it, apply it and get the 10% discount in the total Unacademy Plus subscription amount. There should be no space in between and the spelling should be same. Okay, let's talk about our last question. This is the question. Just a second. Subramanyam, videos like these videos we will have in upcoming days too. Sahil, soon we can have the sessions on the other subjects too. Clear? Now let's talk about it. Guys, see, in this case, when they have mentioned it, the ground state electronic configuration of titanium, okay, what is the atomic number? 22. Clear? It is same as the argon's electronic configuration, but two more terms will be there. That means if you will write the electronic configuration of argon here and you will write these two terms after that, that means it's gonna be same as the electronic configuration of titanium. So instead of writing it completely, they have just mentioned कि बाकी सब same है argon के electronic configuration जैसा, but ये दो terms extra और लिखने होंगे. ठीक है? Next, which state in the standard spectroscopic notations is not possible in this configuration? One more thing, you have to focus. Sometimes students make mistake, they think, oh, it is mentioned at the end, I have to focus on it. Clear? Whether guys, you need to know, whenever we are going to write the the electronic configuration, we firstly fill the one particular orbit, okay, and we fill it completely, then we write the or fill the electrons in the next one. So when S2 is completely filled, in this case what will happen? That means it has been filled first and then we are going to D2. Okay, that means after that we are filling the D orbital. So it's gonna be D2, we are having how many electrons are there? 2. Okay, and the Bright's scheme works very well. So if you were making this mistake, you were focusing on S2 instead of D2, you should just correct that first. Okay, then when you are focusing on D2, now you need to find its all spectroscopic terms. Why? Because you need to check which is not possible, not which is possible. Even in both cases, you need to write all the spectroscopic terms. Okay. Now, in this case, what will happen? The Bright's scheme I have explained in the last session. Okay. Before this, already we had the two sessions of atomic and molecular physics. You can check the series. It is 13th, part 13th. So 12th and 11th session. You can check out that those two sessions will be of atomic and molecular physics. Okay, and you will get to know about all these process steps and everything from those two sessions too if you have missed them. Another thing, what will be the value of L for the d orbital? The d orbital we generally write s, p, d, f like this. Okay, the L values are 0, 1, 2 and 3. So for d orbital L is equal to 2. Okay, now the point is what will be the ml values? They will be minus, plus 2, plus 1, 0, minus 1, minus 2. You can even write the minus values first and then you can write the plus 1. Okay, now you need to make this kind of a structure to get the all spectroscopic terms by using the Bright's scheme. And I am writing it for 2 electrons. So for 1 electron I am going to write all the ml values this side, which are gonna be ml1, and then this side ml2. Okay, for the second electron, how many electrons are there? 2. So for first one we are writing here, for the second one we are writing here. Then I am going to note down all these ml values here, plus 2, plus 1, 0, minus 1, minus 2. Same, in the same way I will write vertically, plus 2, plus 1, 0, minus 1, minus 2. Done? Now when you are going to fill this, what is this process you need to follow? Add vertical as well as horizontally, like plus 2 here and plus 2 like this. So you are going to get 4. You will write it here, plus 1, plus 2, 3, 0, plus 2. That means in all, for writing the numbers on in the first row, I just need to add plus 2 in the columns. Okay, so that means 2 plus 0, 2, 2 minus 1, 1, minus 2 plus 2, that's 0. Then in the second one, when I'm writing, I just need to add plus 1 in these values. Plus 2 plus 1, 3, 2, 0. Oh, sorry, plus 1 should be there, not 0. Correct. Just a second. It's gonna be plus 1, 0, and then minus 1, and then plus 2, plus 1, 0, and then minus 1, minus 2, then minus 1, plus 2, plus 1. You can even do it on your own. Just you need to add this value with this one, this value with this one, like that we are doing. Minus 1, minus 1, minus 1, minus 2, then we are having minus 3, and then we are having 0, minus 1, minus 2, minus 3, minus 4, that's it. Okay. Now, when I have explained the Bright's scheme, I have told you if you are going to observe the principal diagonal elements, which one? These ones, principal diagonal, 4, 2, 0, minus 2, 4. Mainly, I have even told you a trick to prepare it. That's gonna be even L, even spin. That means only for 2 electrons. If you are going to talk about the even spin means 0, and odd L, that means odd spin, that means 1. Only 2. For 2 electrons only 2 spins are possible, 0 and 1. Another thing, even L, that means what is the maximum ml value you can see here? That's 4. So just directly, just to save your time, write 0 to 4 all the values of L. Okay, so L are going to be 0, 1, 2, 3, 4. I have told you for even values of L you are going to take even spin. That means S is equal to 0. Okay, for both. And odd values of L will have the odd spin. So S means 0. For, I am going to write it once again, L values and S values. 0, 2, 4. Even values spin 0, 0, 0. Odd values, what are the odd values in between? 1 and 3. So spin 1, 1. Okay, odd spin. And for what we are writing this? For 2 electron case, 2 equivalent electron case. As you can see, it's D2. Same way P2, same way F2. Okay, so 2 equivalent electron case, that's how you can do it. If you will check the previous sessions, if you have not attended those previous sessions, you will get more tricks, more points from there. Okay, I have explained it very well in the last 2 sessions. We have considered it. Another thing, if I am going to talk about the next step, that is we have to find the value of J. J is going to be equal to L minus S to L plus S. What we mean by this, we just need to calculate it. 0 minus 0 to 0 plus 0, that's 0. 2 plus 0 to 0 minus 2, and like all plus or minus whatever you will add in with 0. If you are adding something, you will get same term. Or you are subtracting, you will get same term. And that's the mod there. 1 minus 0 to 1 plus 0, the gap of 1 should be there. So 1 minus 1 to 1 plus 1, that's going to be 0, 1, 2. Then 3 minus 1 to 3 plus 1, that's gonna be 2, 3, 4. You can see just the difference of one value should be there. Then corresponding to L values, write the spectroscopic terms. That's gonna be 2s plus 1 Lj. What is spin there? Oh, 0. Corresponding to all these spins 0, you will get the multiplicity 1. So it's gonna be 1. What about capital L? When L is 0, it's S. When L is 2, because spin multiplicity for spin 0 will always be 1. Okay, 2s plus 1 is the multiplicity term. And then 2D. Then for 4, it's gonna be S, P, D, F, G. And see, 0, 1, 2, 3, 4. So we are going to get G. Okay, S, P, D, F, G. So it's gonna be 1, G. Okay, next. If I'm going to talk about this one, 1 means P, 3 means what? S, P, D, F. 0, 1, 2, 3. I'm getting F. Okay, 2 into 1 plus 1, 3. 2 into 1 plus 1, 3. Because this spin you will put at this place. Okay, next thing. The values of J. 0, 2, we have already found them. So we are just going to put them here. And 2, 3, 4. Now check. First option, what is the first option? 1F3. Are we getting 1F3 here? No, we are not getting it. Okay, so first option is correct because they have asked not possible term. So first option will be your right answer. Is this clear? Clear? So that's how, like, you can check all the other 3 options terms will be there in the spectroscopic terms we have got, and this is known as Bright's scheme. I hope it will be clear to all of you. Okay. And thank you so much everyone for joining this session. And if you want to attend the more regular live classes by all the top educators we are having on Unacademy Plus for your upcoming CSIR Net Physics exam preparation, then you can take Unacademy Plus subscription. Also, if you will use and you will apply the referral code, that is Anjali Arora, you will get the 10% discount in the total Unacademy Plus subscription amount. No space should be there. You just need to write it as it is. Okay, apply it and get the 10% discount in the total Unacademy Plus subscription amount. After taking the Unacademy Plus subscription, you will get so many benefits like weekly quizzes will be there, doubt clearing sessions will be there, mock tests will be there, PDF of important notes will be available to you. So that's how you will be able to do the best preparation for your upcoming CSIR Net Physics exam. Clear? Also, by getting the guidance by all the top educators, you will be able to know about the exact process, how you should prepare, what are the important things and everything. So thank you so much everyone for joining this session, and whenever you will take the subscription for Unacademy Plus, you can use and apply the referral code, that is Anjali Arora. Spelling should be same, and that's how if I have written it. Okay, I mentioned it here, so you just need to write it like this, apply it and get the 10% discount in the total Unacademy Plus subscription amount. Thank you so much everyone for joining this session. Thank you.